Welcome, friends, to day 11, another day of learning Kubernetes. We have made tremendous success in this journey so far, and a lot is in our way in case of getting knowledge. So let's go ahead and learn about using a service to expose our app. I am so excited as well for today to see what exposing our app is all about. So let us continue. If this is your first time watching, or this is your first time watching, this is the first video you're watching, know that there are about 10 videos in the past that have been covered, and all of them build on the knowledge that has been growing. Okay, so this is not the first stream. So for your advantage, make sure you watch those 10. Okay, then watch this one. You'll be shocked at how much little progress every day makes. So we've been learning for about an hour every morning, and it's been great, tremendous success. Personally, I feel like my knowledge is way up there. So let's continue saying using a service to expose your app. Objectives: learn about a service in Kubernetes, understand how labels and selectors relate to a service, learn expose an application outside a cluster. I see something wrong with my camera. I don't know if I need to change. Okay, this should be now better. Let's continue. So overview of Kubernetes services. Okay. Uh, they say Kubernetes. Okay. Kubernetes pods are motor. Okay. You know the word motor? The word motor in English means something that has an end. Okay. Or that can be destroyed as an end to a life. So they say pods have a life cycle, just like we humans, we have motor. Okay. Or if you watch movies about immortals, beings that cannot be destroyed. Okay. Let's continue. They say when a worker node dies, okay, the pods running on the node are all lost. This should make sense by now. Okay. From what we have learned so far, because we know what a node is. A node is either a virtual machine or a physical machine. So it makes sense that if the machine dies, everything on the machine dies with it. Okay. That is, yeah, that makes sense. So let's continue. So they say, this next statement says a replica set might then dynamically drive the cluster back to the desired state via the creation of new pods to keep your application running. Okay, so the replica set is responsible for driving back. So it knows, okay, one pod has died. One node has died. Let me assign a pod to a new node. Okay, so that we have at least 3 replicas running, if there are 3 in that case. Okay, so it says, as another example, consider an image processing backend with 3 replicas. Those replicas are exchangeable. The front-end system should not care about the backend replicas or even if a pod is lost or recreated. That said, each pod in a Kubernetes cluster has a unique IP address. Even pods on the same node. There needs to be a way of automatically reconciling changes among pods so that your applications continue to function. Okay. So they're saying this is good to know. Every pod has a unique IP address, and this should be the true case. Okay, because in case if the pods had different IP addresses, I mean the same IP addresses, how would the system communicate with them? Okay, so in the world, every computer, every device is identified uniquely because of the IP address, and this only makes sense that we identify the pods on a node using a different IP address. Let's continue. So they're saying a Kubernetes service is an abstraction layer which defines a logical set of pods and enables external traffic exposure, load balancing, and service discovery for those pods. Okay, so it's simply another layer, okay, for exposing a collection of pods, okay, on a node, and enables people from the outside world, okay, to access these pods, okay, and also it enables load balancing. Like for example, if maybe we have 3 pods, okay, and we have maybe 10 requests, the load balancer will be responsible for sharing those 10 requests among the 3 pods, so that one pod does not get overwhelmed by any requests. Of course, 10 requests are few, but that's just an example. We could be talking about thousands of requests, okay, per minute or per hour. So those would be balanced between the what it's called, between the pods. So let's go on. So they're saying a service in Kubernetes is an abstraction which defines a logical set of pods and a policy by which to access them. They're just reinforcing the same point. I'll continue. They're saying a service enables a loose coupling between dependent nodes. A service is defined using YAML or JSON, like all Kubernetes object manifests. Okay, so like we know everything in Kubernetes. If you're creating a deployment, is a YAML file. Okay, so even a service, they're saying we use a YAML or JSON file to create a Kubernetes object. Okay, so a service is a Kubernetes object, just like a deployment is. Okay, then they're saying the set of pods. They're saying a set of pods targeted by a service is usually determined by a label selector. See below for why you might want a service without including a selector in the spec. Okay, so they're saying a set of that set of pods is targeted by a selector. Okay, and they're saying also there's a case in which we can want to have a service without including a selector in the spec. So we're going to see it. Okay, although each pod has a unique IP address, those IPs are not exposed outside the cluster without a service. Okay, so every pod has, like we have been reading since day 1 to day 10, that Kubernetes creates a virtual private network, a private network within itself. Okay, which you can either access when you're inside the cluster, or via something like a proxy, like we say proxy. Okay, or we can access now using a service. Okay, and they're saying the IP addresses of these pods are not exposed outside the cluster without a service. So a service helps us to get access to them. So they're saying services allow your applications to receive traffic. Okay, this is ideally the meaning of exposing it. Okay, so you expose it so that we are able to receive traffic. The same services can be exposed in different ways by specifying a type in the spec of the service. Okay, so this is when you see them saying the spec of the service, they are simply referring to the YAML or JSON spec. It can be one of those 2 types. Now let's move on to the types. Okay, they now talk about the types. They have cluster IP. So they're saying this is the default. Okay, they're saying exposes the service on an internal IP address in the cluster. This type makes the service only reachable from within the cluster. So this is the difference called cluster IP, meaning it creates a service within the cluster. Okay, and this service can only be reachable within the cluster. Okay, so I guess this is like this case is like, can I call it like default? Even without a service, I guess you'd still have this kind of behavior. Okay, so the next type I'm seeing is called NodePort. So they're saying NodePort exposes the service on the same port of each selected node in the cluster NAT, NNT. Okay. So it says makes a service accessible from outside the cluster using node IP, NodePort superset of cluster IP. Okay. So exposes the service of the same port of each selected node in the cluster NAT. So what is NAT? Network address translation. Okay. So you need to think about this carefully to make sure I've understood it. Exposes the service on the same port of each selected node in the cluster. Okay, so the node, okay. So it's about selected nodes, okay. It's on the same port. So the nodes have ports, okay. So the service is simply exposed on the ports of the nodes, okay, using this, okay. So this makes the service accessible from outside using this format, okay. So which means we shall have the node IP address, okay. I'm trying to understand it. We have the node IP address. So every node in the cluster has an IP address, okay. Then we say full colon, okay. Then we specify the node what is being called the node port, okay. So each IP address is given what is called a node port, okay. So get the IP address of the node, semicolon, then the node port which has been given to the selected nodes, okay. So it is a superset of the cluster IP. Yeah, I think now that makes sense, okay. Every IP address, every node has an IP address. Then on their ports, okay, on their actual ports, what is being called the node port, okay, is created on top of it. And this is what the actual service is, okay. This is how you access it using this syntax. Then load balancer, they're saying creates an external load balancer in the current cloud if supported, and assigns a fixed external IP to the service, and it's a superset of NodePort. Okay, so I think this is trying to say that this only works in a cloud, okay, in a cloud environment, and that is only if the cloud environment supports it. Okay, and then gives a fixed, okay, external IP to the service, a superset of NodePort. Then we have external name, says maps the service to the contents of the external name field, e.g. foo.bar.example.com, by returning a CNAME record with its value. So if you want to understand what CNAME is, you need to learn about DNS and A records and CNAMEs. That's when you understand this, okay? But think about it as just a domain name, okay? So it maps the service to the contents of the external name field, e.g. this, by returning a CNAME record with its value. No proxying of any kind is set up. This requires version 1.7 or higher of kubedns or core DNS version 0.0.8 or higher. Okay, so we have cluster IP. This is only internal within the cluster. Okay, we have node. So this one is internal. That's what I get it. These three enable external access. Okay, this one enables external access by exposing a service on the port of each node. Okay, and that will make it outside accessible via node port, the IP of the node to that node port. Okay. Then load balancer creates an external load balancer, but in the current cloud if it is supported. Okay, and assigns a fixed IP address to it. Then external name simply exposes the contents of the external name field. Okay, by returning a CNAME record. So it simply returns the CNAME record. Maybe if this confuses you, you can even Google about it. Okay, and read about CNAME records. Okay, so simply a type of domain record. Okay, you can read about things like air records. Okay, in your free time, you'll get much sense about this. Okay, but CNAME is good to know, so make sure you research about it. Okay, we are getting towards the practical. Says more information about the different types of services can be found using the source IP tutorial. Also see connecting applications with services. We shall see that not now. Additionally, note that there are some use cases with services that involve not defining a selector in the spec. A service created without selector will also not create the corresponding endpoints object. This allows users to manually map a service to specific endpoints. Okay, so because the endpoints are not created, okay, we can now manually map the service to specific endpoints. Okay, I think another possibility why there may be no selector is you are strictly using type external name. Okay, so we have seen the types. Okay, you may want to use this. Okay, we're almost there. Okay, we're almost there to the practical. Hang on tight. Services and labels. They're saying a service routes traffic across a set of pods. Services are the abstraction that allows pods to die and replicate in Kubernetes without impacting your application. Isn't this a good advantage? And then they're saying discovery and routing among dependent pods, such as the front-end and back-end components in an application are handled by Kubernetes services. Okay, discovery and routing among dependent pods, such as the front-end and back-end components in an application, are handled by Kubernetes services. Then they're saying services match a set of pods using labels and selectors, a grouping primitive that allows logical operation on objects in Kubernetes. Okay, so they're trying to say that a service knows which pod to send to traffic using labels and selectors. Then they're saying labels are key value pairs attached to objects and can be used in any number of ways. So they're saying the first way is designate objects for development, test, and production. Okay, now this is how we know how we can split our environments. Okay, you can even add staging, embed version tags, classify an object using tags. Okay, so you can designate objects for different environments, embed version tags, and classify an object using tags. Okay, so I can see a number of nodes. So pod, pod, you're seeing deploy. Okay, I'm seeing app A, selector, service. Okay, this should be either IP addresses. Okay, let us see what all this means. Okay, they're saying labels can be attached to objects at creation time or later on. I like this flexibility. They can be modified at any time. Let's expose our application now using a service and apply some labels. Okay, so we're now getting into practicals, but I would assume these are labels that app A, app A, app B. This is label app A, app A, app A, app A. Yeah, actually they have named it that this is a label. Okay, so app full colon A is a label. Okay, so these three. How I understand this. Okay, these three are the same, are instances of app A. They're all app A's, okay? But at different IP addresses. Are you seeing this one is 10.10.10.1? This one is 10.10.10.2. This one is 10.10.10.3. Okay, all, and you can see the service. Okay, this service. Okay, and I think they are labeling it by this SVC. Okay, and this is the address of the service. Routes traffic, load balances traffic between this. So I'll assume that the type, okay, the type, okay, is this one here, load balancer. So I would assume. Okay. Then this is the replica set, okay, which is responsible for creating copies. Okay. Then this is the deployment object. Okay. So the deployment object, like we said yesterday, a deployment is simply a group of one or more nodes, okay, running, and they could have like storage, okay, networking information, stuff like that. So this is the whole deployment. But this deployment has a replica set, which has replicated, which has now 3 copies, okay, of one app. Okay. So the service communicates with, sends the connection to app A on this IP address, but again there are multiple copies. Then there's an independent app B decided on a different IP address. Okay, let's continue. Saying create a new service. They're saying let's verify that our application is running. We'll use kubectl get command and look for existing pods. So let's go to our terminal. Okay. Kubectl get pods. So it says the connection to the server localhost 8080 refused. Did you specify? Okay, we need to start our cluster first. So I'll clear the screen and say minikube start. Minikube start. Let's wait for it. Okay, so okay, it is done. So let us now try that command once again. Kubectl get pods. Okay, there we are. Says 2 hours ago. Okay, they're saying if no pods are running, then it means the objects from the previous tutorials were cleaned up. Okay, so they're saying in this case, go back and recreate the deployment from using kubectl to create a deployment tutorial. Okay, this is what we did, I think, about 1 or 2 days ago. Okay, so yeah, you can go through it and do it. It's very easy. So they're saying, please wait a couple of seconds and list the pods again. You can continue once you see the one pod running. Okay, so for us, we see that one pod is running. After that, they're saying, next, let's list the current services from our cluster. Okay, so kubectl get services. Okay, so by default, we have cluster IP. Okay, remember what cluster IP does? Okay, it is a type, okay, of service that enables us to access our nodes, our pods, I mean, from within the Kubernetes cluster, okay, not from outside. So this is the default cluster IP. Take note of that, okay. In fact, if I go back here, just to make sure that we can always read this again until it sticks in our minds. It says exposes the service on an internal IP in the cluster. This makes the service only reachable from within the cluster. Okay. So that is it. Exposes an internal IP, which is the type of, this is the internal IP. Okay, which means that we can only access access the pod within the cluster only, not from outside. And this is the default. Okay. All right, let's continue. They're saying saying to expose the deployment to external traffic, we'll use kubectl expose command with the type NodePort option. Okay. So if I've seen this, say kubectl, okay, kubectl expose, okay. Then the syntax is, remember we already created a deployment. So let's say to deployment, okay. Deployment, but actually even before typing this, not CNAME, but deployment, I want to say kubectl get deployments. Okay. So by now, you should know the difference between pod, services, and deployments. Okay. So now this is the deployment we're going to expose. Okay, using a service. So I'll say kubectl, okay, expose deployments, okay, slash this one here, this service, this deployment, I mean, it's what we're exposing. Okay, as simple as that. So kubectl expose deployments Kubernetes bootcamp. Okay, that's why this now makes sense. Okay, I wanted to show you what it actually means. Okay, because when you say get deployments, is that we have what? One deployment. Okay, what's a deployment? Deployment is simply a group of one or more pods, okay, in the cluster on a node which are running. Okay, but remember, to access, we need a service. Okay, by default, there's a service called the Kubernetes, which is of type cluster IP, which means it's only internal. So for us to have it external, okay, we need to use either NodePort type of a service, or load balancer type of a service, or external name type of a service. So you see here, they're saying now the passing subcommand saying type minus minus type, okay, saying minus minus type equals to, then we say NodePort. Okay, I want to make this big so you can see everything. Okay, so we are just saying the type is now NodePort. I want to check the spelling. It has to be in quotes. Okay, so I'll put a quote there and put full quote also at the beginning. Okay, so type equals to NodePort. After specifying the type, then now specify the port. Okay, so I'll say minus minus port. Okay, 80. And actually this makes sense. Okay, so we're exposing the deployment that we have, okay, called Kubernetes Bootcamp, and the type is NodePort. Okay, the type of service is NodePort, and the port is 8080. Okay, so what did they say about NodePort? Okay, NodePort helps us to have access to the to the pods, okay, to the applications running in the pods by, okay, mounting a port, okay, creating a service by mounting a port on top of our nodes. Okay, let us read that again to make sure we understand it. Okay, the saying exposes exposes the service on the same port of each selected node in the cluster using NAT. It says makes a service accessible from outside the cluster using node IP, then the node port. Okay, and it's the superset of this one here. Okay, so it builds a port, okay, on top of the IP address of each node. That's what it is saying. Exposes the service on the same port of each selected node. So we have a port on every node's IP address. Okay, so hit enter. So you see, they're saying service, okay, Kubernetes Bootcamp exposed. Isn't that simple? Okay. So again, just explain again what NodePort is. How I think about NodePort. Type NodePort simply attaches a port to the IP address of the nodes. Okay, and that way, that NodePort service, that type of service exposes it to the external world. Okay, and we are seeing that message that service Kubernetes bootcamp exposed. Okay, if you've not understood it, don't hesitate to ask me a question. Or if you understood it better than I do, you can type it in the chat. Okay, and if you're enjoying this series, share it with people in your network. Okay, and let's grow this community. So where are we? Let's continue. Okay, this is what we did. Now they're saying we now have a service. We have now wow, English. We have now a running service called Kubernetes Bootcamp. Here we see that the service received a unique cluster IP, an internal port, and an external IP. The IP of the node. Okay, so the external IP is what helps us to access it. Okay, so the unique cluster IP, okay, is what identifies, okay, internally. Okay, then the internal port, and then an external IP. So the saying to find out what port was opened externally for the type NodePort service, will run the describe service subcommand. Okay, so kubectl describe services Kubernetes bootcamp. But even before that, I can clear the screen and say kubectl get services. That's it, services. Command kubectl not found. I keep doing this mistake. I have an extra T there. Even services is the wrong spelling. Okay, now you see, we have the original one. Okay, remember this cluster IP, but now we have another one, which is the NodePort. You get. So they're saying for us to see the details, okay? See the details, we can use kubectl describe, okay? So let me delete, I'll copy this, okay? I'll clear, then it's a kubectl describe. Again, we learned about, I think, describe yesterday or about a few videos back. So if you do not know what it is, make sure you watch the previous videos. So describe gives us more information about a resource. Then the resource we want to describe is services. Which service? The Kubernetes Bootcamp service. And there we are with a bunch of information. Okay. So they're saying create an, okay, before that, let us study the result of this. So see that the name is Kubernetes Bootcamp. Namespace, default labels, they're saying app equals to Kubernetes Bootcamp. I think I talked about labels, if you remember here. Where was it? Okay, so they're saying labels are key value pairs attached to objects and can be used in a number of ways. Designate objects for development, test production, embed version tags, classify an object using tags. So you can see that it's a key value pair. The key is app and the value is Kubernetes Bootcamp. Applications, so it's none. A selector is also a key value pair, you see. You see that the label and the selector are the same. The type is NodePort. The IP family policy, single stack. IP families, IP version 4. The IP is this. These are the same. The port is this. Target port, the node port, the endpoint. Okay. Session affinity. Okay. Event, etc. So these are things that we're going to what? I'm sure they'll explain. We shall understand as on our journey to mastering Kubernetes. Okay. But that's how we get information. I don't know if this cannot work, this endpoint here they're giving us. Okay, actually, remember what they said. If you were keen, let me look for that. If you go to NodePort, okay, where is it? Say, where is it? It's here. It says makes a service accessible from outside the cluster using node IP, node port. Okay, so let's go back and see. This one, is this the node IP? Okay, so this is the node IP, then the node port. Okay, and this is the target port. Okay, so let's try it out. Okay, this is me experimenting, being stubborn. Carl. Okay, probably this is not the way of doing it. Okay, this was me just experimenting, but we lose nothing by experimenting. Okay, we shall I guess we shall see what to do soon. So let's continue. So they're saying create an environment variable called NodePort that has the value of the NodePort assigned. Okay, so yeah, this has been something common. We don't need to cram it. Okay, so I'll copy all this. Come here, break this, clear the screen, paste. Okay, so the NodePort is this. Okay, which means what I was talking about was wrong. Okay, if I do this command, okay, I think this value 31735, okay, is not listed amongst here. So my calf command wouldn't work. Okay, so it's the node port. Okay, and if you look at this command carefully, okay, they're saying kubectl get services, and the service they want is Kubernetes bootcamp. Okay, then I'm showing -o is an option that helps them to pick a Go template. Okay, and now this expression is trying to parse to a specific value within the template. So they go to index, then specs.port, okay, maybe the first one at index 0. Then from this, okay, they pick the node port. Okay, so I'm not a master. I don't know how Go templates work, but this is my guess, just using my general knowledge of software engineering. Okay, let's continue. They're saying now we can test that the app is exposed outside the cluster using curl, the IP address of the node, and the externally exposed port. Look at me, who was being very, 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 I was being very impatient. So here it is, okay? So this command minikube IP is something that we can run independently, okay? Because remember what NodePort is, like I showed you. Forget my experiment which failed. Where is it? NodePort. The node IP. When someone talks about NodePort, the NodePort service, in your mind, just know it's all about the node IP connected to the the node port. Okay, as simple as that. Node IP to the node port which has been created. So to find out the node, so here, if we go here, they're saying minikube IP. So if you find out the minikube IP, I can even type it here. Say minikube IP. Okay, so this is the IP address. Okay, cluster IP. Then we have the node port, which is this one here. Okay, so they're going to combine this IP, this port. Okay, that's the syntax, ideally. Okay, so we can access it like that. So if I copy this whole command and I paste, okay, but still we get nothing. So let's continue reading. They could have a solution for us. They're saying note, if you are running Minikube with Docker Desktop as the container driver, a Minikube tunnel is needed. Okay, and remember I am using Docker Desktop. Okay, just to show you. See, Docker Desktop is running, so which means I need a Minikube tunnel. Okay, so they're saying this is because containers inside the Docker Desktop are isolated from your host computer. Yeah, that's correct. So they're saying in a separate terminal window, execute Minikube services Kubernetes bootcamp URL. Okay, they're saying the output looks like this. Okay, they're saying because you are using a Docker driver on Darwin, the terminal needs to be open to run it. Yeah, okay, this makes sense. That is why actually I was wondering why these curl commands are not working. Okay, so I'll copy this command. Let us open what they're calling a tunnel, minikube tunnel. So I'll go to this other, I'll go this side, clear, and then paste it. Okay, so you see, says because you are using a Docker driver on Darwin, the terminal needs to be open to run it. So now I can go here. See now, then use the given URL to access the app. Okay, so it is important to follow documentation. If I ended here, okay, I would be frustrated. Okay, which means if we are not using Docker desktop as the container driver, okay, then there's no need for us to have a minikube tunnel. Okay, this would work flawlessly. So we can now use that IP. Okay, can now use this. Can copy this, go to this other terminal. No, hit say curl, then that. You see, then it works. Say hello, Kubernetes bootcamp running on Kubernetes bootcamp, blah blah blah. Okay, even from the browser, it should be now possible. If I copy this entire address, go to our browser, paste, you see, there is it. Okay, same message, same goal. So that's how we have access it using the NodePort. Okay. All right. So what else do we need? Okay. I think that's it. Let's continue in. So they're saying as we get a response from the server, the service is exposed. Okay. So the first step, if you read here, was creating the new service. And we create the service by using Kubernetes expose. We expose the deployment. So I get this means that without a deployment, you cannot expose a service. So type NodePort. Okay. We see the information about it. Okay. We got the actual node, doing the actual node port. Okay. Then they build the URL. But again, if you're using Docker desktop, make sure you create a tunnel like that. Okay. And then, yeah, that's the address for you. Now they're saying using labels, they're saying the deployment created automatically a label for our pod. With the describe deployment subcommand, you can see the name or the key of that label. Okay, copy this, clear the screen, paste. You see we have the label. See labels, app equals Kubernetes bootcamp. Okay, that's the label. Okay. So they're saying, let's use this label to query our list of pods. We'll use kubectl get pods command with the -l as a parameter followed by the label values. Okay, so kubectl get pods -l app equals to Kubernetes bootcamp. Okay, so this label, simply this is what they are trying to fetch. Okay, so because I also want to master it, I'm going to type it by hand. I'll say kubectl get pods parameter -l like that. Okay, and you see we get it. Okay, so they're saying you can do the same to the list to list the existing services. Okay, so using the label, okay, we've been able to query or find out the pods. Okay, so you're saying they can do the same to services. Okay, so I guess L is a parameter, meaning short form for list. So I'll do the same thing, kubectl get services -L, paste in the label. And there we are. Okay. And we have the Kubernetes Bootcamp service of type NodePort. Okay. If you're wondering why the service is called Kubernetes, it's because we gave it a name. I guess it was named after the deployment. Yeah. We didn't give it, but it was named after the deployment. That's why I went up to be sure. Okay, they're saying get the name of the pod and store it in the pod name environment variables. Okay, so in the same thing, you're getting it, they're extracting it, okay, from a template within the Kubernetes configuration. Okay, and I guess it's like a YAML. So let's simply copy this, come here and paste. Okay, so this is the name of the pod. Okay, and actually if you run this command, you'll see that the same name exists. Okay, but if I quickly look at this, I think they simply run that command kubectl get pods -o. I think allows it to get information from a template. Okay, go template, then specify the template. So they're trying to pick this value here called name. Okay, so they pass from range to items. Okay, then they get metadata.name, then they look for a new line. Okay, then mark the end. Okay, I'm not a good at go template. That's just a guess. Okay, I hope that is explained later. Okay, then they're saying to apply a new label, we use the sub command followed by the object type, object name, and a new label. Okay, so to apply a new label, we use the label sub command followed by the object type, object name, and the new label. So they say kubectl label pods. Okay, so label is the sub command. Okay, so kubectl label pods. Okay, we get now the pod name. Okay, and the version. Say version equals to v1. Now they're saying this will apply a new label to our pod. Okay, you're saying we pinned the application version to the pod, and we can check it out with the describe command. Let's first do this. Okay, so it says pod Kubernetes blah 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 labeled. It has been labeled. Okay, so on top of the name, the pod name, which is this, okay, a version has been pinned to it. Good. So they're saying we can check it out using the describe. Okay, so I'll paste that. Okay, wow, this is a lot of stuff. Let me first clear to make sure you know what I'm looking at. Okay, so I'll expand this slightly, move up. So the name, I'm looking for something like labels. Okay, so are you seeing the version? The version has been pinned. Okay, so apart from this, you still have pod. Okay, equals to Kubernetes Bootcamp. Then I'm seeing something. I'm seeing pod template hash is this. Then you see the version. Version equals to v1. Okay, so yeah, it makes sense. So they have pinned the version. Okay. All right. So the actual label is this actually. So kubectl label pods, pod name. But in fact, we can even do it without having to do this. For those of you who are worried about this whole syntax, okay, let me show you. Let me try to do this. Okay, I'll say kubectl get pods. Okay, so this is the pod name. Okay, so I'll copy this pod name. Then we're going to to label. Okay. Now say kubectl label. Okay. Label the pod name. Okay. Then I can put a label, pin a new label. I can say x equals to y, something like that. Okay. So if I hit enter, saying server does not have type, a resource type, Kubernetes bootcamp, blah, blah, blah. Oh, I missed the resource type. Okay. So it's supposed to be like this: kubectl, the subcommand label, then the resource type pods. Okay. Pods, then the pod name. Okay. Then the label x equals to y. So the thing unknown command lable. Instead of label, I put lable. Yeah, I'll practice until I learn. Then finally, it has been labeled. So if you don't want to go through this whole process, you can find out the pod name mechanically. Then now we can find out what you can describe. So I can clear the screen. I say kubectl get pods. Okay. I copy the pod name. Then I can say kubectl describe. Okay, what do I want? Which resource do I want to describe? Pods. Which pod? That pod. So if I go up, I think I have another label here, which has been pinned. X equals to Y. Yeah, that's how I understand it. So the advantage, of course, having a variable like this, okay, like pod name, is that you don't need to copy and paste the entire pod name, which is too long, like you saw me doing. Okay. But I did it so that you understand the goal of the things. So if you're loving this, yeah, like this video. And let's grow this community. Okay, what else do we need? Okay, the thing, and we see the pod. Okay, now they're saying deleting a service. So they're saying to delete a service, you can use the delete service subcommand. Labels can be used also here. So say kubectl delete service, okay, -l, then you pass the label. Okay, like that. So first of all, I can say kubectl get services. So you see, we have two services, okay? Kubernetes, the default one of cluster IP, and Kubernetes bootcamp of type NodePort. Okay. So to delete, they're saying you can say kubectl delete services -l. Okay. We put in the label, okay, of the service. Yes. Then says deleted, okay, from default namespace. So if I try to use this previous command of get services, you see it has been deleted. We only have cluster IP. Previously we had two. Okay, this says this confirms that our service was removed. Confirm that the route is not exposed anymore. You can call the previously exposed IP and port. Okay, so we can do that. This was our IP, okay, that we used. For us, we're running on Docker. So if I say curl paste, you see it's not working anymore. Okay, because we have deleted it. Then of course, first, if you do this, it will and you're using the Docker driver, it won't work. You'll have to do like they suggested earlier. They say this proves that the application is not reachable anymore from outside the cluster. You can confirm that the app is still running with a curl from inside the pod. Okay, so we can do this. Okay, you can use kubectl exec, run it in interactive mode, the pod name, curl this. Okay, so you can copy all this, paste, and there it is. Let me clear the screen. You see, there it is. But remember, we had to curl, okay, from inside the pod. Okay, this is the same as saying, let me break it down for you. If I say kubectl get pods, okay, so we have one pod, okay, without a service, without the NodePort service. Then we can say this is the same as saying kubectl, okay, execute in interactive mode, okay. Then you paste the node name. So this pod name is simply a variable storing all this, okay. All this Kubernetes bootcamp 6 blah 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 is stored in this, but this time I'm just showing you what is happening, okay. Then let me copy this curl, okay. So if I hit enter, okay, it needs at least one command, okay. One command which we can put is like the bash. You can say minus bash, okay, to enter the bash. So you see we're inside. We're inside the what? We're inside the pod. So inside the pod, I can do curl, okay. I can say curl to that IP address, okay. Says could not resolve curl. Okay, I typed curl twice, okay. I can just paste it once. You see, and there we are. Let me clear the screen. Okay, you see, it is working because we are inside. Okay, so I can exit it, okay, by typing exit. Now I'm back, okay, and then outside here we can now, instead of having to enter inside it, we can say in the interactive mode we want to pass the command that we want to run, okay, saying minus curl, like that. Hit enter, and that's how we do it, okay. kubectl exec. Remember what we learned yesterday, or 2 days ago. Exec is for executing a command in the pod. This means interactive mode, then the name of the pod, okay. Then we pass the sub command. In this case, it is curl, okay. I want to test the endpoint, and you see it is working. The only difference is that here now this one here is replaced by the variable called pod name, which is storing the same value, okay, which is this. And of course, this makes it shorter and nice, okay. So you see the same result. So pod name is simply a variable holding this value here. Okay, so the rest is the same. So we see here that the application is up. This is because the deployment is managing the application. To shut down the application, you would need to delete the deployment as well. Okay, so that's enough for today. Okay, we have finished this successfully. Let's meet in the next video. Again, like, subscribe, share it with people in your network so that we build a powerful community and learn together.